In the continuing theme of industrial control products and components, these are some panel indicator lamps, and they're available in a variety of different sizes and different colours, and they're all LED based. And they're not actually too bad. They're not super mega bright. It's hard to actually evaluate the brightness. The little tiny one here is visible, but I wouldn't say in a brightly lit factory it would be quite hard to see, but that's partly because of the compromise because of its size on the power circuitry. The other ones aren't actually too bad. They're actually a good modest illumination, strangely. Well, not so strange as it turns out. The yellow one, despite being based on older technology than the blue gallium nitride type one, looks really bright. It's very impressive. So I'm just going to go back to normal intensity and we can take a look at these. So I'm back at a normal intensity level. They're not so bright, and you can see a slight shimmer because there's no smoothing involved in these. They're really just a functional light. You can see they're still very visible as indicators, and this little white one is super dull. It just doesn't, it's lit. I can see it's lit relatively clearly, but as I say, in a bright factory, you'd probably have to shield it to see it. However, that's because of the size. And what's interesting about these is that in the case of the blue one, you can take this off to actually put a legend underneath if you want. And it's just got a single blue LED right in the middle, just a single chip. However, for the yellow one, which had a really interesting surprise, because as I was checking these out before the video, I discovered something really interesting. This one has, it's got 8 chips in it, and you can see a sort of pattern going on there. And there's a reason for the pattern. The middle ones, it seems strange because normally I was expecting these to be inverse parallel type arrangement, but it's a really unusual configuration, which explains why the 4 in the middle look fairly constant while the ones on the outside are sort of shimmering a bit. But I shall unplug these now I've done that, and we shall take a look at what's inside them. And I have to say, I've not had these open yet completely. I've had the front off, but not the inside. So I'll just put this power supply out the way. That was the quick test I was using there. It's an old electrical connection device. Well, still available. I've just made a video about it, which I'll be putting up round about the same time as this one, just showing what's inside the quick test and indicating in the comments where, not comments, but the description of the video where you can get it. However, back onto the subject in hand. So, looking at these lights, they've got various different configurations. Some of them have a tiny little surface mount LED in the middle, the sort of brighter, say the white or the blue or the green have that. Whereas the other ones, like the red, have slightly tinted plastic and then a matrix of the LEDs underneath. And these are all done the same style. It's a little plastic dish with a circuit board sat in the bottom, and it's one of those like cob type, chip on board type arrangements where they've actually put the LEDs on as chips and then gold wires, and I can show you this I took some close-up pictures, because close-up pictures are good. So here's the red one, which is this suspicious splodge, and is that visible? Yeah, it's actually underneath is it underneath the plastic? I think it is. Yeah, a slight discoloration. But as you can see here, you can see the physical chips, the tiny little chips bonded on, then the gold wires jumping across the pads. And likewise, the white one with the yellow LED has just got the fairly chunky white. In fact, I think there's a difference between the two white ones. Is there? Hold on. Yeah, this one's got a much bigger LED than this one. That's interesting. But roughly the same situation. But in this instance, although the LED is soldered across, it's got the diode chips are once again bonded directly onto the actual circuit board at the back and then covered in resin. And there is one other picture if I can find it here. Yep, the blue one, which is I've toned this down. I was trying to actually trace the tracks, but in this case they've just got the tiny little chip, the blue LED chip, bonded straight on with the jump wire again. It's not actually, I guess the reason they did it with the white one was purely because it made it simpler having the phosphor pre-attached. And I've traced this out. It was fairly easy. I actually used the blue one to trace the tracks. And let me see if I can find this now. Have I just buried that? Yes, I have just buried that. Here it is. it's a very simple arrangement. The 4 diodes basically form a bridge, and you've got the AC coming in these pins, and then it gets rectified and then passed through the LED, and then there's current limiting behind this, which I can see a capacitor through this, I can see a resistor. I'm just guessing that it is just a resistor and capacitor in here, but what will be interesting is to see the ratings, because this lamp is rated 220 volts. But just out of interest, I got some that were rated 380 volts to see what sort of difference there was if the capacitor ratings were different. Now, the other LEDs, like the red one, I had trouble tracing out the tracks, and it didn't help that I just thought, well, where's the notepad in fact, and I'll doodle what I was there. I've just got stuff everywhere here at the moment. So, when I tried tracing these out, I was expecting it to be like this. Notepad. I was expecting to see, there are 8 LEDs, I was expecting to see, since there are no rectifiers, I was expecting to see 4 in one direction, 4 in the other, with just half of them lighting on each half of the sine wave. And it's a fairly common approach. I've seen this used elsewhere before. It's very simple. It means that in this case, theoretically, all you need is a capacitor and a resistor to limit the inrush current, and that's it. And another thing they can do that, since it's all on the board anyway, they can bond it across like that, so the maximum voltage, reverse voltage, any of these LEDs will see is the forward voltage of the other one. It's a very simple arrangement. But it's not like that. It was weird. That's what I was expecting. When you're expecting something like that, and you start tracing it out, nothing was just fitting. And here's what it actually is. It's a bridge rectifier formed from LEDs. So I'll draw this as the classic bridge rectifier. So let's say, for instance, we'd normally have a diode going like that, and like that, one like that, and one like that. And when AC is applied across here, normally with a bridge rectifier you'd have the positive and the negative would come out, it would rectify the AC into DC. Except these are LEDs. And it just kind of makes sense the way they did it. And then the load across it is more LEDs. 1, 2, 3, 4 LEDs across the bridge rectifier. And it's so clever because it maximizes efficiency, so to speak. So when this end goes positive, the current flows through this LED, making it light up, through those LEDs, making them light up, through this LED, and goes to the negative. So with that polarity, 6 LEDs out of the 8 are lit. You swap the polarity, you make this one positive, and you make this one negative. And it's this LED is lit, the 4 LEDs in the middle are lit again, they're the ones that weren't flickering, and this LED is lit. So basically speaking, 4 LEDs are lit in both halves of the wave, and the other 2 alternate. 2 are lit in one half and 2 are lit in the other half. Very clever indeed. So it took me ages to work that out because I actually had to trace it all out. I was going like, the way I drew it out initially when I was tracing it was I drew it as 1, 2, 3, 4, 5, 6, and then the 2 LEDs going in the opposite direction, like that. So, and then I had to actually, it was so, I was so not expecting it that I couldn't even suss initially that it was basically a bridge rectifier. And that's how it was connected, like that, if I remember correctly. Yeah, very neat. So again, if that was positive, it would go 1, 2, 3, 4, 5, 6. So all those 6 LEDs would light. But when that went negative, it would go through this, down through these 4 LEDs, and then back up through that one. Yeah, very neat. Quite surprising. It was quite a nice thing to discover. But let's open these up then and see what's inside. So this one is a 220 volt one. The assembly, the way these are connected to, they've got these little terminals in the back that have the sort of rising clamp, rises up. Well, it's a little plate, it's a very common industrial connection. And you can pop the back off, it's just clipped on to reveal those little screws. And when you do that, even if you take them out, I was expecting, oh, I just got a little tingle off that, that's because it doesn't have a discharge resistor. Let's make sure I don't get another tingle off that, shall we? I think I've already just discharged it through me. So the leads, these are sort of two pressed in bits of metal. And they've got the two leads coming up from down below. I'm not sure how easy it's going to be to disconnect those. Oh, and there's a wee threaded insert underneath, so I'm just going to cut those. I could desolder it, but I'll just solder more leads on afterwards. Oh, this is proving a wee bit footery. Oh, yeah, that is proving very footery because they're in so deep. Oh, there's one. As I say, I've not had these apart yet. I'm kind of intrigued to see, they've got the different voltage options. You know, you've got the 110 volt and the 240 volt, or 220 volt, and then the 380 volt. I'm guessing these are more commonly sort of maybe Chinese industrial voltages, the 380 volt in particular. Our voltage over here is supposedly 400 volt, our three-phase type voltage, where you measure across two phases. It is just a capacitor. In this case, it's a 400 volt capacitor. Is that just 100 nano? Yep, 100 nano, 400 volt, and the resistor is brown, black, red. That's 1K. Okay, that's interesting. Oh, actually, you know what? There's another thing. The back of the circuit board is fully visible in there. I thought that was just going to be poked into a little plastic dish, but it seems to have been sealed in some way. I don't know if they stuck that in and then applied the goop. Oh, it's quite sticky inside as well. Okay, let's get one of the other ones. What voltage is this one rated at? Oh, this one is rated. Oh, no, it's 220 volt. That's annoying. What about this one? This is rated 380 volt. Let's open up and see what rating the capacitor is. I'm guessing it might be a 630 volt capacitor. I'm not 100% sure. And once I've done this one opened and checked the component values, we'll look at this tiny little dinky one. I'm not keen on tiny little indicators like this operating at 380 volts because the connections inside are just going to be so... I've had so many instances in the past that you've gone out to work on a panel and you found the problem with the panel is the control circuit was dead because one of the indicator lamps had exploded. And the reason was that they were using these tiny little lamps, you know, little miniature Edison screw type lamps, but at ridiculously high voltages, like 415 volts or something like that. So what we got here? Got the 1K resistor again. And the capacitor is rated, it's rated rather vaguely, it's not very clear. 100 nano. It says 104K250. Surely that's not the voltage rating. I hope not. 104K250 NISC91. Is that a 250 volt capacitor and a 380 volt indicator? Oh, that's not very impressive. So let's say that's I wouldn't even rate that for 240 volt then. Oh, that's not very impressive. That's a bit disappointing. It makes me wonder if they're all the same because this is another 220 volt one. I might get some from other sources and take a look at them. But looking at the little dinky one now, this is quite interesting because it comes open quite easily. And all it's got inside is a resistor, a 300K resistor, and the LED. And the LED is, to make sure it doesn't flicker too much, it's a dual inverse parallel chip LED. It's basically got two LED chips in the one cup. And if I power this up through a resistor, one side light of the cup lights, and then you power reverse polarity the other side lights. And I will say this is going to get pretty warm because when you do the maths, let's get the calculator in. When you do the maths in this, that indicator is designed for 380 volts, so ignoring the LED voltage, which is just nothing. This thing is, the resistor is dropping almost 100% of the power. The LED is nothing. So let's say 380 volts divided by the 300,000 ohm resistor. So that's going to pass about 1.2 milliamps through the LED, times the 380 volts, because most of that's being dropped across the resistor, means the resistor is almost dissipating half a watt. And to me, that means this little indicator is going to get pretty toasty, and it's going to heat the LED up. Although they do have it in the positive lead, which is better. Well, it's obviously the positive lead isn't really 100% the positive in a bipolar LED, but they've not got it in the cup that holds LEDs, so that's going to at least give some heat separation. But again, yeah, I'm not overly thrilled at the idea. I think I'd rather not use small indicators. I'd just rather use big ones. And talking of indicators, I was on a job a while back. All I had to do was move 3 small panel indicators. And they were in a receptionist's office, and they were just marked boiler 1, boiler 2 and boiler 3, and it was just 3 boxes in the wall. Just little boxes with a little tungsten lamp glowing red indicator just to show the boilers were okay. And I took the first one off the wall because they were putting new furnishing up, and they were just being removed temporarily, and then they were going to be put back on. And I took the first one off, and I measured the voltage inside across the lit lamp. I couldn't turn the boilers off because the factory was still was active at that point. So carefully took it off and measured the voltage across the indicator lamp. Just one of these little tiny indicator lamps, and it was 12 volts AC. Okay, no problem. I insulated the wires up, took the box off the wall and tucked everything in so it was just ready to be covered, and then the wires brought through again. Then I went on to the next box and I took it off, just carefully tested, same indicator, same boiler thing, 12 volts AC. So that's fine. Took off the third box and just thought, no need to test this because it'll be 12 volts, and it was 240 volts, and it gave me quite a shock because you just get complacent. 3 identical indicators, 3 identical boiler systems, and 3, identical boxes. You just assumed it was going to be 12 volts all the way if the first 2 had been 12 volts. So I went into the boiler room to take a look, and the 3 boiler panels, when I opened them up, you could see where the tails came off the bottom, the terminal racks at the bottom for going to these indicators. And the first 2, boiler 1 and 2, had a little 12 volt transformer screwed to the bottom of the panel. And I get the feeling that maybe they'd done that because the lamps were failing so quickly, because the 2 40 volt lamps don't last very long. And they also tend to fail quite dramatically, sometimes taking the control circuit out too. And so the boiler 1, boiler 2, these little transformers at the bottom. Boiler 3 didn't have the transformer, it was just this 240 straight out to those connections. So the moral of the story there is just never assume, just because everything seems so obvious it's going to be low voltage, that's a good way to get a shock. If you just make the assumption that the third one is going to be the same as the others. But yes, these are visually nice. I'm really disappointed, really mega disappointed at that resistor, that capacitor rating. I mean, even in 240, as I say, that's just taking the shine off that. I could change capacitor, but that kind of defeats the point. I think I may get some more of these and just take a look at them and just see if they're a similar arrangement. I'm pretty sure the 250 in that is the 250 volt rating, so that's not that great. It suggests that maybe that resistor will be needed at some point. But other than that, the LED arrangement in them, and particularly that LED bridge rectifier for both the red and the yellow, was very interesting. And visually, they're quite good lights. It seems a shame that they're not quite electrically up to standard. Rather than write these things off, because I certainly wouldn't use them in industrial application, I've just been playing about them. And if you keep the 1K resistor in, and just bypass the capacitor completely, they light at a modest brightness on 12 volts, and because they're not, because they get the rectifier built in, or the LEDs configured as a rectifier, they'll work in both their polarities. In fact, if anything, at the moment it's displaying a bit of a 6 like a dice. If I swap the leads across, it just displays a completely different pattern of LEDs. The other ones, like the white and the blue, also light brightly with the 12 volt supply if you just bypass the capacitor and keep the 1K resistor. So that's at least one bright side of that. It's not a complete waste. If you consider that capacitor is rated 250 volts, if that's what it is rating, does appear to be so, and you consider that if it says it says on it that these are rated for 380 volts, which is presumably a Chinese industrial voltage, 380 volts AC times 1.41, which is will give the peak voltage. The peak voltage of the sine wave will be 535 volts, which would exceed the rating of a 250 volt capacitor by 2 times. It would be over twice the rating, so that's not too jolly. I would guess that hopefully, if they're just using standard capacitors, that the ones designed for 110 volts, and they do these in 12, 24 volt, 36 volt, I think, 48 volt, 110 volt. I'd guess up to about 48 volts they may be using resistors, but from 110 volts, if they use the same capacitors, then they would be okay for a 110 volt supply. It's just the 400 volt one and the 220 volt indicator was fine. But the ones where they've just really cheaped out for the much higher supply voltage, that's not fine. Recoverable, but as again, as I said before, it's not a particularly ideal situation.